Alright, last class period we left off talking about storage systems, and that kind of leads into chapter 13. Chapter 13 is all about Windows and how to use Windows, and then in chapter 14 we're going to look at how to install Windows. Now, I would be willing to bet most of you have installed Windows before, and most of you have used it quite a bit. So the big thing to take away from this chapter for the test, for the CERT exam, is to pay attention to some of the old XP stuff, especially if you haven't been using XP in a while. Remember, this is an older version of the test. You're not going to have anything except maybe one or two Windows 7 questions on there that they've thrown in there recently. And there'll be absolutely zero Windows 8 stuff on it. I look for both of those to be on the next version that comes out in January. But there won't be anything on the one for y'all from there. Alright, so our objectives. We're going to differentiate between Vista and XP, which should be pretty easy for everybody to do. We're going to talk about some things that are part of a Windows machine, like the registry, virtual memory. We've already talked about file systems, but I'll briefly go over those again. We're going to talk about Windows interfaces, the Explorer, My Computer, the control panel, and so forth. We're going to talk about essential operating systems that the machine needs to boot and to run. And finally, we'll talk about disk partitions and files and folder management. We'll also talk about some of the command line functions, which are great if you're ever stuck somewhere in Windows. You can usually drop to that command line and figure out what's going on with the system. And then we'll talk about the device manager, the registry editor, and system restore. Finally, we'll look at optimizing Windows. So, this is a good question. How did we get to where we are today? And honestly, we could do a whole class period, if not more than one, on the history of computing and the history of Windows. But things started in 1969 with the first openly available operating system being Unix. That was the first thing that you could actually buy. Previous to that, all computers basically didn't have a standard operating system. Things were programmed on them as they were needed. In 1973, something called CP/M came out, and this is a forerunner to DOS. CP/M is the reason that DOS and even a command prompt in Windows has that very familiar C:\/ look to it. CP/M was the system that started that. CP/M later became part of Novell. In 1975 and 76, X Windows came around, and that was really the first graphical interface, and that was on Unix systems. In 78, Apple made their first computer that was graphical with what's called the Lisa. Lisa was the first graphical interface there. In 1980, QDOS became PC-DOS, and that was the first DOS really available for IBMs. Then in 82, one of my favorites, the Commodore, came around. The Commodore was one of the first computers to multitask, and it could do 32-bit processing. My first actual computer, period, was a Commodore 128, and I didn't have a monitor. It actually hooked to a TV screen, and instead of a hard drive, it had a cassette drive, and it actually used cassette tapes just like you would record audio on. And I remember one of the first programs I had for that was Miss Pac-Man. It would take about 17 minutes to load it, so you started up loading, you'd go do something else and come back, and then maybe you'd be able to play a game. In 1985, the first version of Windows actually came out, Windows 1.0, and it was not very successful. It was horrible. There wasn't a lot to do with it. Windows 2.0, you see, is not mentioned on here. It never actually got released. They played around with it and just never did anything with it. But then Windows 3.0 came out, and that was really one of the first successful graphical user interfaces. Then in 93, 3.11 came out, and that was a real big step because that one was network capable. So now we've got networking built into the Windows system. And with all of these first ones, you would use your system would still have DOS on it, and DOS would run in the background, but then you could boot it into graphical mode. That took place on the non-server side of things, even through Windows 4 and into Windows 95. 98 was one of the first ones where you didn't have an actual DOS underlaying. And then on here they say 2000 Windows ME, the first OS to try to forget. That's a good idea. ME was one that had zero DOS in it at all, and it was not very compatible with everything. They didn't leave any of those subsystems in there, so all your old games and stuff that ran fine wouldn't run on ME. And because of that, ME was just very terrible and not very successful. In 2001, we kind of entered the modern era with Windows 2000. And like I said, we could go on with further from that. But you see what kind of brought us to where we are today. So there are some differences in the different versions of Windows. And this again is a reason that they're fixing to change the test again. Vista had a feature called Windows Arrow. Windows 7 had the Windows Arrow interface. It gives you translucent windows and three-dimensional windows. Now Microsoft has since dumped that. Windows 8 does not have the Arrow interface in it. And the reason is they decided to kind of go backwards. Now they're going back to make computers where you can you don't need as much memory and such to run things. The Windows sidebar was another feature of Vista that's not in XP. And the sidebar was the idea that you could put all these little things on the side and they'd run and tell you news and weather and whatnot. Windows 8 has done away with those as well. In Windows 8 you've got the Metro interface, that takes care of everything. You had a new start menu. In Vista the run prompt was removed, but you could put it back in. Instead it was a start field. It was a search field. In Windows 8, as y'all have heard me gripe in class quite a bit, there's not actually a start menu. And that was a major change for Windows, because the start menu has kind of been a staple since the modern era of the computing operating systems here. Everything since about 95 up has had a start menu of some kind, whether it be called Start or the Orb or something like that. So here is a kind of a minimum hardware requirement, just so that you can look at between the different versions of operating systems. Vista, you need 800 megahertz processor. XP, a 233. The minimum amount of RAM is 64 megs. I would not try to run it on anything that small. But these are the actual minimums that you need to install it. And a DVD or CD for all of them. I kind of hate that they put that in there, just for one reason. You actually could get XP on a set of floppy disks. You needed quite a few of them, and it took forever if you had to install it that way, but it was possible. So when you're upgrading to any of these, there is a compatibility wizard that you can download off of Microsoft's site. Now the Vista compatibility wizard is gone from their site now. The 7 one is still available, but now of course everything is the 8 compatibility wizard. And it would tell you if everything you had on your computer was capable of being upgraded. Now here you also get into a weird situation that I'll just explain. I don't know if you'll see this on the test, because you're not going to see a lot of Windows 7 stuff. There was not a direct path to go from XP to Windows 7. If you wanted to upgrade from Windows XP to Windows 7, what you had to do was upgrade your computer to Vista, and then upgrade Vista to Windows 7. With 8, they have taken that and really taken it to heart. A lot of people didn't upgrade to Vista to 7 because of that. With 8, you can upgrade from any of these directly into Windows 8. So if you're XP, Vista, or Windows 7, you can upgrade directly. The only rules are you have to stay in the same architecture. And what I mean by that is if you're running 32-bit, you got to stay 32-bit. If you've got a newer machine and you've moved on to 64-bit, you can upgrade it with 64-bit. So here's what the compatibility wizard looked like. Select a compatibility mode. Alright, so a very key component to Windows is the registry. And the registry in Windows is basically all of the settings. It's kind of a database that has all of the settings on the computer. And it's divided up into 5 sections, and each of these sections are called hives. And the way that you get to the registry editor is to run regedit from the run command. So this is what the registry editor kind of looks like. Again, you know, my computer's running Windows 8, so mine's looking a little newer than if you run regedit on yours, unless you've upgraded. But you see, here are your hives. You've got root, user, local machine, a users, and a current config. And in each of those, root links to extensions for programs. Current user stores the configuration for the current user that's logged in. That's also where all the Microsoft Office stuff gets stored. Local machine is hardware and software that's on the computer. Users has all the users for the computer, and current config has the current hardware for the computer as you're logged in. And you see, some of these things are stored in there in a couple of places, and the reason is this stuff is very important. Without a good registry, your system just will not boot. So here they're showing their example of the registry editor. You see, they've expanded the one that I showed earlier. To expand these, you just click next to them and you can look at the different things in them. I encourage you to explore the registry in your computer, but be very, very, very careful. Don't change anything unless you know exactly what you're doing, because changing a registry entry can completely mess up your computer. So some of the important registry file associations are in the System32 folder. The default settings from HKey are there. This is also where SAM resides. That's your Security Accounts Manager. Software is the settings for the local machine. Then System has the local machine registry entries. The user files are stored by the system and the registry in the ntuser.dat file, and that records the preferences. Then userclass.dat is the preferences for the application and local settings. Here they're showing just an individual key and what's in that key, so you get an idea of what the registry looks like. Alright, another component of Windows, and not just Windows, but in Windows it's called virtual memory, is space that can be substituted for RAM. And the reason for that is that we have computers now that are multitasking, so we run 3 or 4 programs at one time. It's not uncommon for me to have Word open on one window on one screen and Excel on another one, and maybe I've got a Google open on something, Chrome looking something up. So computers are fine with doing that, but each of those programs takes up memory. And if I run out of my physical RAM, what I have to do is store things to the hard drive. And virtual memory causes a performance decrease because it's much, much slower than actual RAM in the computer. But it won't be used unless it's necessary. So what you can do is look at your performance monitor through perfmon.exe, and if pages show that they're consistently near 100% use, it might be an indication that you need to add more memory to the computer. And that's one way to definitely speed up a machine that's pretty cheap these days, is just to add more RAM. So components of XP has a program called NT Loader, NTLDR. And that is the Windows Loader program. That's what actually starts the system. Boot.ini has the settings on how to start it up. ntdetect.com detects the hardware. And then NTOS kernel is the kernel that loads the boot process after being initialized. Then you have a program called HAL. And HAL is one of the keys of what makes Windows what it is. HAL is the hardware abstraction layer, and it translates Windows to the hardware. That's what allows Windows to run on every different computer, because the HAL layer falls down below Windows, and HAL reads everything and sends the right commands to the hardware. Then the system key and the registry will have the system config, and then finally device drivers, and they're loaded according to what's stored in the registry. In Vista, NT Loader is called Boot Manager. That's what starts the thing up, and then BCD is the boot configuration data. To my knowledge, Windows 7 uses the same thing, and I have not heard or seen this, but I believe Windows 8 uses the same thing as well. We still have our hardware abstraction layer below that, and then we have the system key, which is the registry entry that determines the config, and then again device drivers, which are loaded according to the information in the registry. So the Windows interface is how the user interacts with the system. There are a variety of them. The start menu, again, this is what we did use until Windows 8, what everybody used. The start button would display shortcuts. My computer was similar to the Windows Explorer. Here is a basic example of what Windows Explorer looks like. Again, it's going to look different on your machine because I've got Windows 8 and you've got probably 7, Vista, or maybe even XP. So the taskbar across the bottom gives information about what's running. The system tray is the bottom right, and that's where the icons are. That's your notification area. That's where things that are going on your computer pop up. If program's running in background, it'll put a little icon there. The command line interface is where you get to your C prompt. And to do that, you open the run command, type CMD, and you'll get something that looks kind of like this. This is your command prompt. And this is where you can also do quite a bit of diagnostics. For example, if you're not sure you're able to get on the internet, you can type the command ping. And if I ping something out on the internet like 8.8.8.8, if I get a response, then I know my computer is actually on the internet and it's able to get out. On Vista and on Windows 7, you have what's called the network. On XP, it's called My Network Places, but that's where you adjust the settings for the network. So there's also a thing called file indexing, and it allows you to search faster. The disadvantage is that it can slow down other system functions. To fix that, you modify it to only select the folders that you think need to be indexed. And that's under your control panel, system maintenance, and indexing options. So far, I have not found those settings in Windows 8. I don't think you have an option. I believe everything is indexed in 8. So that leads us to disk petitioning. And you have to petition a disk before you can actually write files to that disk, before you can install an operating system on it. So what you do is, first of all, you boot up Windows, and you can let Windows do it for you in most cases. If you're adding a drive, you can do it from the disk management console, which you can right-click on your computer and go to Manage and find that. There are two different petition types. There is a primary and an extended. And the reason for these different types is that as drives got larger, you might want to put more petitions on there. But there can only be 4 primary petitions on an individual hard drive, and only a primary petition can be used to be bootable. Extended ones cannot be bootable. So the maximum number of operating systems you can put on one computer are 4 with 4 different primary petitions. Extended contain what are called logical drives. You can create an extended one and then put all the drives you want in those, but those are not bootable. Those are only accessed after the operating system boots up. So here they're given an example. The first hard disk starts with C. Then they've added a non-bootable drive letter, an extended petition. Or finally, you could add an additional drive. They show here they've got some unpetitioned space at the end of the way that they've petitioned this one. So something else you may need to do is format a disk, and that sets the system where it is ready to take data. You have to choose what file system to use. And the reasons, as we talked about in the last section on files, drive efficiency, drive security, or multiple boot requirements. FAT32 is recommended for the older systems. That was kind of the common one that everything used. NTFS is all the new ones. They say on here NTFS will not work for Linux installations. That's not true anymore, but it was in 2009 when this test originally came out. NTFS, these are some of the features we'll go over briefly because we talked about them in the last class. Access control and compression, the practical limit of a size of 2 terabytes, individual recycle bins for each user, encryption capability, larger files can be put on them, they can be indexed, and you can have a quota. So from command line, there are some commands you should make sure you know about. And 3 in particular, MD, CD, and RD. MD is to make a directory, CD is to change into it, and RD is to remove it. So if I go to my command prompt over here, and I'm not an administrator, so I don't know if this will work, I can make a directory called 1. So I made a directory called 1. Now I can dir to get a directory, and there is my directory that I just created called 1. If I want to go into it, CD, and into the directory CD1, you see my command prompt changed to show that I'm now in C:users, HORTO 000 in the directory 1. CD ... will take me back out of it, and RD1 will delete that directory. In Windows, you can do that with your GUI interface, with your graphic interface. Here they're just showing that, and I don't think theirs are very clear, but they're showing the folder options. Mine look a little different, but here I think will be a little clearer for you to read. Whether you want to show or not show hidden files, hide empty drives, always show icons, never thumbnails, always show in menus. There are several options you have. File management is the same as folder management. You can create and delete files. Different types will have different links. If it's a .doc file, for example, Windows will link it to Word so that you double click on it and it'll open it in Word. Some binary types, .exe and .com, a special type of text file, .bat is a batch file to run commands. And they want you to make sure you understand that .exe, .com, and .bat are all examples of extensions. You'll notice these use the 3 that we talked about in last class from the 8.3 era, where a file name could only be 8 characters long and could only have 3 characters after the dot in the extension. Back then as well, you couldn't put a dot in a file name. So some of the attributes a file might have is an archive bit, and that indicates whether the file has been backed up. If the bit is off, it doesn't need to be backed up. If the bit is on, it means something has changed in the file since the last time the bit was turned off, so that means it should be backed up again. Read-only, of course, means exactly what it sounds like. You can't modify or change it. A system file gives you a warning if you try to delete it. A hidden file won't show up on the list. If it's compressed in Windows, it'll show up as a different color, and if it's encrypted, it'll show up as a different color. You can modify those graphically, or from command line, you can use the command attrib to modify some of those files. NTFS, again from last time, full control, gives you access to everything. Modify means you can change the file. Read and execute, you can read and execute it. Read means you can read but not execute. Write means you can overwrite it. And list contents just allows you to view what's in a folder. Here the creator or owner has full control by default. If you create the file, you're the owner of the file, so you can then deny or grant these permissions to other users. Unless you're in a network setting, and then I may, as an administrator, have it turned off so that you can't change the permissions I set for you on your files. Other tools that you may need to use are called are defrag and NT backup. We talked about backup last time. Defrag is used to get rid of files that get fragmented on your hard drive. And the reason for fragmentation goes a little bit beyond this class, but I'll kind of explain it so y'all have a rough idea. When you write a file, it writes to the first free space until the whole drive is full. When you delete a file, all it really does is deletes the pointers to those files. It doesn't actually delete the file itself. That is why there are tools you can run that will allow you to go back in and recover a file even after it's been deleted. But because of that, ultimately when the drive is full, it goes back and starts writing over the previously erased space. Well, if I deleted an 8K file and I have a 12K file to write to its spot, it's not all going to fit there. So 8K of the file goes in the first spot, and then 4K will have to go somewhere else on the drive. Because of that, I just fragmented the file. Well, that's fine, it works, but it's slower to be able to read because the computer has to read in 2 or 3 places to get that one file. In fact, it's very common for a Windows machine to have thousands and thousands of fragments. So what you do when you run a defrag is it goes on and it moves all those files around and tries to put them back together. Check disk is another one. Check disk checks the hard drive for errors. Format prepares a drive to accept data. Be careful using format because it erases everything on the drive. Format is something you have to do to a new drive. Most things come formatted now already, though. Format is actually kind of still just around from the old days of when you would buy floppy disks. Floppy disks usually came from the factory unformatted, so you had to format it, which wrote over it all the first time to make it ready to accept data. So there are different types of commands to be aware of. Internal and external. And internal commands are built into the command kernel. External ones are that have to be loaded from the hard drive. And you just basically need to know the difference in those. Some of the internal commands, like we talked about, make directory, md, cd, change directory, rd, remove directory. del is a delete command, copy to copy files. dir, you saw list the contents, and then erase is the same as the del command. Table 13.6, they say in the book, has got a full list if you kind of want to look at those. Alright, so more system management tools. The device manager, you get to that from right-clicking on My Computer, Manage, and System Tools. The task manager, which I'll show you, but it looks completely different in Windows 8 than it did from 7 or before. The task manager shows you what's running in the computer and what it's using. So you see right now with me running Camtasia, Camtasia is using 3.9% of the CPU of my computer and 99 megs of memory. The registry editor I didn't close. It's using 0 memory, but it's still using 0 CPU, but still running 2 megs of memory. Performance from here also will show you what your computer's doing and how much of it you're using. So I have 76 processes open, but I'm only using 14% of the total capacity of the computer right now. And then under details, it'll show all of the things that are running. So you see on my computer I have several instances of Chrome open right now. The event viewer allows you to look at some of the different events that are that can happen on your computer. msconfig is another good one. This is msconfig, and this one does look relatively the same. You can go in here to boot, and you can tell it different options, like if you want to boot it to make a boot log, If you want to turn some of the services that boot on and off. If you have more than one startup item, you can do those from here. Under Tools, it'll show you some of the things you have, like clicking About Windows will tell you about the Windows computer. If I do that on my machine, I get this. This is telling me, about Windows 8. I'm running version 6.2, build 9200 at the moment. And then finally, Remote Desktop. That's one I use a lot. Remote Desktop allows you to access a desktop from another PC. I tend to plug my laptop in, for example, when I get home, but I stay on my desktop. So if I want something off the laptop, I'll just Remote Desktop into it to copy whatever I need. So some troubleshooting things: the Device Manager, the Event Viewer, the Microsoft Management Control. My Computer and Properties is another one. The Task Manager you just saw. You can look at the boot log and the syslog text files on XP or 7 or Vista to see what they say. The MMC console will give you some good information. This is the Device Manager to give you an idea, and it shows all the different things that are on your computer and whether they're functioning or not. If any of these are not functioning, what it'll show is a little exclamation point inside of a triangle. I don't have anything on my computer not functioning right now, which is good, but that means I don't have a way to show you that. Here is the Event Viewer to kind of give you an idea as well, and it keeps things like hardware event, Windows logs. Here's application logs if something didn't run or failed to run. Camtasia has a problem earlier. It must be reinstalled after you upgraded Windows. I had an Office problem earlier. That's probably recorded in here. Office failed to load. Just locked up when I tried to load a document. So that's probably recorded in here. And then the Task Manager that we looked at. So that is a quick rundown of Chapter 13. We talked about Vista, XP. I threw in some 7 and Windows 8 for y'all. We talked a little bit again about FAT32 and NTFS and some of the ways to optimize Windows and then the system management tools. Thank you all for watching.